Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up,
So, hey folks, so I'm Ben. I'm going to talk about how data engineering fails. Before getting into all of that though, I do want to give a quick bit of background about myself. So I am one of the founders of Mode, which is a modern BI tool designed around data teams. It looks like this. It combines a kind of code-first tool for analysts, as well as visualization tools for everybody else, all in one place. I also work closely with other folks on our team, including our internal data team and our product and marketing teams, to help make decisions about like where we think the market is going and the sorts of things that we want to build in the future. And so as a big part of that, I spent a good bit of time talking to customers and the community, which mostly manifests as me yelling at the internet on a blog, which you can find here. Now, so this blog is probably most of the reason I'm here today. Over the last 6 months or so, I've kind of published a number of Oscar the Grouch-worthy posts about various things that are popular in the data industry and how they might fail. So things like Snowflake, Fivetran, dbt, these are some of our favorite tools in the space. And so I had these posts on how they might actually not work out. So why do that? Part of this is actually just like I'm a grump. Back in 7th grade, I was cast as Scrooge in a school play. This is me acting. And my face kind of stuck this way. But the other reason for this, and kind of the more useful reason, is actually inspired by a movie called World War Z, which is this sort of mediocre zombie movie from a decade ago. So it's kind of a generic zombie movie with a generic zombie plot. There's a virus infects people, people eat people. The whole world is sort of overrun by these zombies, except for Israel. And so there's this scene in it where Brad Pitt is talking to this Israeli guy, asking how are they prepared for the zombie apocalypse when nobody else was. And the Israeli guy says, if 9 of us get the same information and we all arrive at the same conclusion, it's the duty of the 10th man, no matter how to disagree with that, sort of no matter how improbable disagreeing may seem. And so this 10th man has to start thinking about this from the assumption that everybody else is wrong. And so the point of this exercise is not to say that like a zombie apocalypse will happen, or in my case that Snowflake or dbt will fail, but to think about how that could happen and what we would do to prevent it, or what would happen if that actually came to pass. If you prefer, this kind of like thought process is also called a pre-mortem. This is a much less exciting way to frame it than a zombie movie to me, so I don't use this one. But that's the idea. And so that's what these posts were about. They basically were about contemplating a future in which these companies aren't kind of the inevitable successes that we often see them today. And so in each blog post, I wanted to assume, like, what happens if we go down these companies' dark timelines? Shout out community. And that like 5 years from now, the hype around these companies or these technologies has died. Like, how would we arrive there? And so for what it's worth, like, this isn't just an academic exercise for a blogger looking for some topics to come up with, because sometimes the next big things don't actually turn out to be the next big things. And so that's what I want to do today, is play this kind of 10th man role about the next big thing, which is data engineering. It's something that's very popular today. We see headlines like this, like it's the sexiest job of the 21st century. And so the question I have is, something after all is going to like end up being the next Hadoop. It might be data engineering, and if it is, what would that look like? So I've got 6 ideas for how that might happen, starting with like kind of boring ideas and ending on kind of the increasingly implausible and outlandish. But that's where I want to start. So the first idea, first way in which data engineering might fail is it's boring, and nobody actually wants to continue doing this job. So what I mean by this is if you go back to headlines like this, like data engineering is the real sexiest job of the 21st century, like, why is real in quotes here? And the reason for this, as I'm sure like lots of you are probably familiar with, is 10 years ago, the Harvard Business Review put out this article that said data science was the sexiest job of the 21st century, so sort of a precursor to that last one. And there's a lot of hype around this idea, and this became kind of a very popular concept of like data science and thinking about big data was going to be the next big thing. It's now a little bit passé, and so like if the first sexiest job of the 21st century didn't last a decade, we should probably by default be a little bit skeptical that the next one will actually last for that long. But the skepticism about like data engineering should actually probably go a little bit deeper than that if we think about why data science didn't actually end up being kind of the hype job that we all thought it might be. And so that problem starts with this article from the New York Times. This, I think, actually came out in 2014. And it identifies like one of the problems with data science as it sort of manifests itself over the last decade. And a lot of the work, as this says, is this kind of janitor work. And what they mean by this is, again, I'm sure most people are familiar, is a lot of the work that data scientists do is this kind of data wrangling, data munging, or again, as they called it, data janitor work. And that data scientists, and kind of a very common and well-known stat now, or something that we often cite, that 50 to 80% of their time is spent in this kind of mundane labor of collecting and cleaning data. And this is a pretty common complaint about data science, that like this is what the job actually is. It's not this fun stuff that we thought it would be. And so Harvard Business Review also eventually kind of said the same thing. They published another article a couple years after that first one that said, hey, the sexiest job of the 21st century is actually turns out it's pretty tedious. And we need to change that. And what did they mean by that? They said, you know, in a 2012 study, we characterized these 5 different jobs that a data scientist has to do: discovery, wrangling, profiling, modeling, reporting. And unfortunately, and the unfortunately does a lot of work here, the first 3 are where data scientists spend most of their time. And this isn't what we want to do. We don't want to be doing this discovery, wrangling, profiling, like data cleaning work. And another kind of like seminal article in the data engineering world, this one by Jeff Magnuson, who ran some data teams at Stitch Fix, put it even more bluntly when he said that nobody enjoys writing and maintaining data pipelines or ETL, that it is the ultimate hot potato in the industry. And this, like, if you think about it, this makes all of this hype around data engineering and analytics engineering kind of weird. That if we think, like, what is the job of a data engineer or an analytics engineer? And so if you look at, like, say, the folks from DBT Labs who've kind of done more to define this than anybody else, the job of an analytics engineer, and you could also extend this to a data engineer, is to clean data sets and model data and to transform and test and deploy and document data. And like, this is all the stuff that we didn't want to do as a data scientist. And now suddenly it's the cool job. And so like, again, that makes it pretty weird, where the thing that we thought was the cool job was data science, and now we're distracted by that because we have another job that is just the bad parts of it. And so this to me like suggests that it's actually not data engineering that's cool, it's the fact that it's kind of the shiny new thing that's cool. And that's what makes it appealing. And so the shiny new thing doesn't last very long. It's very possible that like that ends up getting distracted by the next thing. And so all that we thought data engineering was just kind of moves on from there. So moving on to potential issue number 2. We all get fired, and for this time because we cost too much. So there's actually kind of 2 problems here. The first is, like, according to Indeed, who collects numbers on these sorts of things, software engineers in San Francisco make about $147,000 a year. Data engineers make $9,000 more than that a year. And so right off the bat, that makes us a pretty expensive bunch. That if like we are more expensive than the job that everybody talks about being very expensive, seems like kind of a problem. And so it's actually worse than this, where it's not just like the role is expensive, is that we also buy a lot of expensive tools. And to see what that looks like, I actually went back through, there was a data conference from a few months ago hosted by the folks at DBT Labs called Coalesce, where a bunch of people presented about like their data stacks and the tools they were using and things like that. And wanted to go through those talks and figure out, like, did anybody share the tools they were using? And can we like estimate roughly how much those things would cost to support? And there's a handful of talks that did that. Here's a slide from folks at Miro, where they outlined the tools that they were using in their current data stack. These are the ones that you'd have to actually pay for, and that are strictly data tools if you remove things like GitHub, which might be shared with an engineering team. In this case, roughly, these tools probably cost between $50 and $100K a year. So that's on top of the cost of actually having the data engineers. Here's another example of a data stack. This came from folks at Shipyard. These are the tools you'd have to pay for. If you'd estimate this, it's probably about 100 to 200K. Here's another one. This one comes from Condé Nast. So if you're a much bigger company, a much bigger enterprise, you got a whole bunch of stuff. These are, again, the tools you'd probably be paying for. How much is all this? It's tough to actually estimate, really, but probably somewhere on the order of $250K to $1 million. And that's not cheap. And so, like, in a world that looks like this, which is kind of the new world that tech is in, where we're outside of this golden age, where companies are calling like 2023 the year of efficiency, people may start thinking twice about spending this kind of money on things, both as tools and as employees. And so I know like what some people may be thinking is like, yeah, okay, fine. We're a little bit expensive, but we're worth it for how valuable we are. If you don't love us anymore, then fine, we'll walk our fine ass out that door. To which I would say, like, good thought, but the truth hurts. We still might get fired because we're not actually that valuable. So this is possibility number 3, is actually like we all get fired because the work we're doing not only costs a lot, is not that useful. So to think about this, consider the job of like what is an analytics engineer? And again, you could extend this to data engineering more generally. This is what we're supposed to do. And so we are supposed to basically model data to empower end users to answer their own questions, or kind of is commonly known in the industry like self-serve. So how are we at this? How good are we at self-serve? Well, this is what people say about self-serve. This was a recent blog post from the folks at Monte Carlo. Self-serve is a data's biggest lie. Or if you prefer, here is a similar sentiment from Katie Power, good follow on Twitter. As she says, like, not so sure that self-serve works. And this is kind of how the current impression of self-serve right now is. People are saying, like, hey, does this actually work? Is this actually solving the problems we thought we needed to? And so like, this is the value that we're providing, is we've spent all this money and time to try to build these tools and maybe not be delivering on it. And so some people may also be thinking like, hey, okay, fine, but we also do this other fancy stuff. We build tools for important real-time applications and all these kinds of cool things. How is all that going? Like, we're doing these other valuable things. It's not just about like self-serve and BI. So for these things, like real-time data, so in 2014, Forrester, who is, sort of thinks about these kinds of things, said that real-time architectures are going to become prominent in 2013. In 2016, Forrester then said, actually, real-time will be a must-have for digital winners. 2017, streaming is going to finally be reborn. 2018, companies are going to drive towards real-time. 2020, companies will start to integrate real-time into their analytics systems. 2022, it's finally going to be a reality. Like, there is a clear trend here, which we have been a year away from delivering on some of these promises for a decade. And you can do this exact same thing for a bunch of the other things that we say is really important about data engineering. Predictive analytics, so if we want to look at that, we have the same story, where it's going to be operational in 2014. We're behind the curve if you're not using it in 2015. It's going to be mainstream in 2016. There will finally be progress on it in 2018. It's going to be a key component of digital transformation. And then businesses are going to be investing in it in 2022. Like, again, we have been doing this for 8 or 9 years, saying this is going to happen, and we're still not quite there. Machine learning, again, same story. It'll establish itself in the enterprise in 2016. No, enterprises will embrace it in 2019. It'll be mainstream in 2021. No, in 2022. And so all of this kind of tells this same story, where we have these things that we say are going to be really valuable, but they're just not quite here yet. And so we see headlines like this, too, where it's like, hey, companies need to become more data-driven. They need to become quickly. They need to do this very quickly. And yet, again, we never quite seem to get there. And like, we can only cry wolf about this stuff so many times. And so to illustrate this, I want to consider a hypothetical where a legacy company, like this headline says, actually tries to become more data-driven. And like, suppose that you have a big public company, for instance, that puts out a press release like this, that says, hey, you know what? We've decided to modernize. We're going to announce a multi-billion-dollar investment in data and infrastructure and all those kinds of things. And the press release has these kind of like headlines that say, hey, machine learning is not just a buzzword. Artificial intelligence is here to stay. The future of tech is calling. All of this like big stuff that says, hey, we're going to finally do these things that we as an industry have been saying people need to do for a while. What would happen to this company's stock price? Like, how would the market react to this? Would they say, great, you're going to finally do it. We're going to go, like, we are now very bullish on this company. Or did the market look at it skeptically? Like, how would companies actually respond, or how would investors actually respond to this? And the thing is, we don't have to guess, because JP Morgan did this. So in 2022, this is exactly what JP Morgan did. They put out a press release that had these headlines. The title was a bit different. It said, this $12 billion tech investment could disrupt banking. But they put out this exact plan. And this is what happened to their stock price. In 5 days after this announcement, it went down 14%, compared to the market going down by 5%. And actually, the day of the announcement, so that first day, it dropped by 6%. And so, like, that's not to say that if someone asks us, hey, like, what exactly do we do here? Our answer is, well, we spend a lot of money and we create maybe a little bit of value. But it's not exactly saying that's not our answer. That, like, if we want data engineering not to fail, we need to have a better answer than this. And right now, the market is very skeptical of our ability to do that. So that's possibility number 3. On the bright side, there's only 3 more. So possibility number 4 is we get replaced by tools. And this one actually is not that crazy because this is already kind of happening. So if you go back to the first like tech job that I had, I worked at a company called Yammer. It was bought by Microsoft back in 2012. And so we built a data stack there that looked kind of similar to the modern data stack, but with tools that, a lot of those tools didn't exist at the time, so it was with tools that were different. But it was similar in structure. And what that looked like was this. We had a few data source systems. We had the Yammer application itself. We had tools like Marketo and Salesforce. We extracted all of that data and loaded it into a data warehouse, kind of data lake thing called Cosmos. At the time, it was proprietary to Microsoft. It is now something you can buy on Azure. We did some transformations into it. We loaded it into Vertigo, which was an analytical warehouse. And then we did a bunch of analysis on top of that data on a home-built tool that we called Avocado. To do all this, we had to have engineers build these pipelines. We had to have engineers keep Cosmos up. We had engineers building this internal transformation tool. We had a DBA who had to run Vertica. And we had engineers who had to build this reporting tool. And so all told, there were about 10 data engineers that supported this system. This was for a company of 400 to 500 people. We had about 10 data engineers running our data stack. If you consider what this would look like today, it wouldn't look like that at all. The way we would do this now is we would buy something like Fivetran to manage these pipelines. We would place like both of these databases with a tool like Snowflake, or given where we are, with something like Starburst. We would use a transformation tool like dbt to run these transformations. And given who I am, we would use a tool like Mode for the BI layer. And so all of this would take like what, I don't know, 1 to 2 engineers maybe? Like we are 80 to 90% sort of already replaced by a handful of tools that we can now buy off the shelf. And this is only using just like a tiny subset of the tools that are now available. If we want to do a ton of other things, we've got like dozens of tools to choose from that can also kind of replace what we're doing. So if we wanted to do data observability, we've got a bunch of tools for that, or things like data quality, reverse ETL, or orchestration, reverse ETL, real-time databases, ML platforms, all of these other categories. Like we've got a ton of options here for tools that we can choose to do the jobs that used to be filled kind of by data engineers. And so we're already seeing a lot of this kind of replacement of engineers by these tools. That's a trend that will probably only continue. And sort of what's more is one of the hard parts about like managing all of this is you've got all these tools that you've got to make talk to one another. And now we have a kind of meta layer of tools, like tools like 5x, that are actually building a layer on top of that that help you manage all of these tools as well. And so this is, as it says, lets you build your data platform without building anything. And so we're increasingly seeing this kind of trend where all of the work that data engineers used to do is getting replaced by like what vendors are now sort of providing out of the box. So we also might not just get replaced by tools, we also might get replaced by people, which is kind of failure possibility 5. And to explain this, I want to use kind of 2 of the most buzzy concepts in data today. One is the data mesh, which people have talked about here at DataNova. The second is data contracts, which people have also talked about earlier today. And so I don't want to like touch on too much of the specifics of these topics. There's a lot to talk about. These are controversial things. People will disagree. I'm not here to say that. If you step back, though, like at the core of both of these concepts is essentially decentralization. It's the idea that when data used to be like this sort of centrally governed thing by a central team, central like set of data engineers, and everything was sort of run through that sort of authoritative governance layer within that team, we're now moving to a structure that looks more like this, or at least these trends of the data mesh and data contracts are starting to do this, where it pushes out responsibility to other teams. That how data is produced is now sort of governed by data contracts or owned by those other teams that manage those data contracts. The logic behind how data is transformed can be owned by other teams through things like a data mesh. And so like if this kind of trend of decentralization continues, data engineering is not going to outright fail, and that we won't have data engineers anymore. Like we're not going to outright have that problem, but we won't have data engineers that look the way they do today. They'll have a lot less ownership over business problems and be this kind of more support function for these other teams that are actually owning these data processes. So in other words, like data engineering won't fail, but it'll just become more of like an infrastructure maintenance role, like a DBA or the IT team, responsible for the office Wi-Fi. That they're critical, sure, yes, absolutely, but they're not nearly as autonomous or strategic as we might like to think of data engineers today. And so again, this is like a trend that we are generally seeing across the industry about kind of decentralization. If that continues, then more and more of the responsibility of what data engineers do might get offloaded to kind of their business partners instead of with the data engineering team themselves. So getting down to the last one here. So the last way we'll fail is kind of the obligatory, we get automated away by AI. This one, though, is I think it's important to kind of distinguish how this might happen. It's easy to just say, like, Chat GPT or I guess Bard will replace all of us. But I think there's actually more interesting ways that this would actually happen. And so the way to explain this is if you like abstract away kind of what data engineers do, generally it looks something like this. So data engineers, we start with a bunch of messy data and kind of disparate sources and things like that. We clean it up, we put it in some nice, neat boxes, it's nice and organized, and then we put some tools on top. And those tools can be like BI and reporting, they can be operational data apps, they can be data models or systems designed for other kind of data platforms. But the important thing is, on the other side of all of these apps, there are people. And so that may be an analyst using a BI tool, it may be a developer using the data models to be able to build machine learning products. But the point is the people consuming these end systems are often people. Which means that this data actually needs to be nice and sort of semantically organized and human understandable. It is people who are consuming it, and therefore like, it needs to be something that people can actually reason about. But increasingly, we're starting to see things like this. So this was a blog post put out by the folks at Patterns, where they attempted to replace a SQL analyst with a bunch of ChatGPT prompts. We're still early stages in this, but this is clearly like an effort that people are trying to make, is say, hey, these jobs that used to be done by people might evolve from this into this, where they're done by AIs. And if we have this, if we have these like chatbots that are the things that are actually consuming data as opposed to humans, then it really raises the question of, does this data need to be human readable, or does it need to be like machine readable? Does it need to be readable by AIs or readable by an analyst? And so if it needs to be the latter, or the AI one, I suspect it looks different than it does today. So an example of this is something like Parquet. So Parquet is a data format. It's an efficient data format to be able to like store and query, but it's not something that humans can really reason about. Like if you try to open a Parquet file, it doesn't really make sense. It's not like opening a CSV where you can just view it. You can't really open a Parquet file directly without having something that can translate it for you. And so you could imagine there being kind of a relational Parquet, where the way that we organize data and the way we relate it together is not these nice, neat tables that we're used to, but it's something that is designed for the kinds of AIs that might actually be consuming it. And if that were to happen, then it might actually make a lot more sense for an AI to clean it up. It might actually make a lot more sense for that data to be transformed, not by a human, but by something that can actually reason about it the way that the kind of end systems will reason about it. In which case, again, we've now lost our jobs, this time by being automated away by one of these AIs. So that's my 6 ideas, the way in which we fail. We're replaced, fired, automated, replaced, fired, quit a job we hated. But the last question here is kind of obvious. Like, okay, what do we do about it? Like, Israel built this giant zombie wall. What is our version of that? This didn't work in the movie, by the way. The zombies just kind of jumped over it, but you know, whatever. So the answer here is obviously like generative AI. No, it's actually not. It's generative alliances. So to me, actually, like the biggest problem that we have, the thing that underlies a lot of these issues, is we got to be more creative. That like just how movie studios get stuck on making these remakes over and over and over again, we seem to get stuck on trying to solve these same problems. And it's not actually clear how much we need to solve them. Like one of the reasons why we get so stuck on something like real-time or predictive analytics isn't just because the technology is hard, but it's because the end value of producing this may not actually be there. That we're building something that people may not actually really need. And so the question is like, then how do we avoid making yet another Batman, which they are apparently making? And so my answer to that is like, I don't know. The answer is not in this talk. It is not in this conference, actually. It is, as like Steve Blank famously said in the 4 Steps to Epiphany, it's not in this building. The things that will make data engineering last have nothing to do with us as data people or as data engineers, and everything to do with like the people around us that we're trying to solve problems for. That we should be trying to understand what those things are and start from that, rather than starting from these different technologies and saying, hey, we need to have better systems for data engineering to survive. What we actually need to do is solve the problems that these people are trying to solve and adjust to that kind of new reality. So like my last bit of advice on this is to listen to fewer data people. So things like this blog, like and subscribe. But actually like read something else. There we go. Read something else. Like don't read this blog. Like the answers are not in this blog. The answers are at places like this. So if you want to understand the problems that like managers have, go read Charity Major's blog. You want to understand engineering, go read Will Larson's. These are the blogs that will actually answer these questions of like what we need to do to not fail. because they'll explain the problems that different departments have. They'll explain the sorts of things that we need to solve for this to actually work. It's not going to be something that we come up with. It's going to be a problem that they have, and then we can be creative about coming up with solutions for that. So with that, I will stop. Thank you, everybody.